Appliance repair community. My name is Reggie Williams. I was a technician for 10 years, and I went from tech to your Encompass rep.
Well, hello everyone. Hope everyone's having a wonderful day. It's getting a little chilly over here. I know that you guys are in the north and in the about the same. What am I looking for? Central time that I'm in. Most of that time zone is a little chilly this morning. Even though it's about 2 o'clock here, we're still at about 50 degrees. So that's not too bad, but it could be a whole lot better and being down about 40 degrees. So today, everybody, we're going to talk about Whirlpool Range basics. We're going to basically cover your heating elements inside your range. We're going to have, if it's an electric one, we have I've got some information on that. If it's a gas one, we got some information on that. Then we're going to go through the surface elements, and kind of go through the surface elements. Usually, the surface elements, today's ranges are most of them. Hey, Randy, Johnny, great to see you again. We're going to go through and we're going to talk about the infinite switches. Those are basically not too bad on any of the ranges. Then we're going to actually talk about a infinite that we have. So we're going to just go ahead and get started. All right. So we're going to talk about checking the elements on a range. Okay. You can use this for any range out there. It doesn't really matter if it's a Whirlpool, how are we doing, Rupert? Good to see you here. We can use that for any range. Anything from a Viking to the Whirlpool to any other range out there. Okay, these are basic information. Okay, so number one, what's my meter? What's its role whenever I'm going around checking anything? Okay, so my meter's role is actually to identify the power. Okay, it's critical to remove the operating power source from the unit being diagnosed. The most important method is to unplug the easiest method is to unplug the unit from the wall. Or the outlet, or turning off the power to the outlet at the box. It just kind of all depends on what your situation is. Nowadays, there's not a range that is hardwired in. If we get into an oven, most of those are hardwired in, and you'll have to turn the power off at the box. So you don't want to. If I'm in just a single or a double oven, or if you have a single oven and a microwave on top of it, that's most of that time is going to have to be done at the box. And I just make one simple flip of the switch. I know that I have 240 volts, so it's totally different than just a 110 outlet. I don't have to go through all the ones and find. Usually, on a normal, typical house, I have a dryer, I have the range, I have a air conditioner, and if I have a pool or a jacuzzi out back, I may have an outlet there, but that's only 4 breakers, so I'm not going to be tied down flipping through every single one and having to reset all the breakers for everything. Because as well as I do, about half the time they're not even marked. So, with 220 volts, I only have around four breakers that I'm going to have to flip to know which one it is if I have nothing. Okay, so Um, so with the unit turned off, we're going to measure in resistance. Okay, if I have to turn the unit on, I have to be very careful because I have power supplied, and I can either short out my meter, cause an arc, and actually blow the circuit on the oven itself. So we have to be careful, and that's the reason I tell everyone to go ahead and unplug it or turn it off. Okay. So what am I going to do? What am I going to use? I'm going to use either there are two actually scales that I'm going to be able to use on measuring resistance. I can either go through just to go to the ohm scale. Okay. If you look at the meter right here in the round and the circle there, we get a high from a high amount of ohms all the way down to a very small amount of ohms. Then right next to that, there's a little buzzer. Okay. Everybody knows what the buzzer is. So if I turn my meter to my buzz section and I cross the leads, it beeps. Then I know that I have continuity going through that. Okay. So here's a typical outline of a range. Okay, I have an L1, which is showing right there. I have a neutral, which is our yellow wire. Then I have an L2, which is the red wire, and then I have an earth ground. So everybody today should know exactly what an earth ground is. We're going to take about 2 slides worth of introduction, and it should be pretty easy for you to know what an earth ground actually is. Okay. By definition, the earth ground is exactly what it sounds like. Really, it's usually it's a ground that is physically and electrically connected to the earth, and it's via usually one of 3 types of materials. Okay, usually it's a copper line, a copper rod, an aluminum rod, or an aluminum alloy. I will tell you that if you're using, doesn't matter which one it is, the copper rod was much more expensive. So they went to an aluminum rod that drives, it's about somewhere around 6 feet. You drive that all the way into the ground. It's got to be, that's how you get connectivity to the earth. So they have gone to an aluminum, and then now they have an aluminum alloy. I actually just ran a line out to my trailer, and I actually had to drive the aluminum alloy rod down into the ground. So what will happen is, coming from the box, okay, there will be an earth ground rod coming from that box. It is around. It's about a number 4 wire. It's copper. They're all copper wires coming out of the box. There is no aluminum alloy or anything else. It's a heavy gauge copper wire that you stretch that out. There is a fitting that comes in the box. It is actually either brass or also could be copper. The one that I got was a brass. So what happens is I now take this rod that I have driven into the ground. I've left it up. Mine I left up about 2 inches on it, and after I drove that into the ground, I take that little clamp, I put it in, and I tighten it down. Then that is my earth ground. Okay. As mentioned previously, the ground terminal, the earth ground, is physically tied to the chassis, which in turn is connected to the ground wire within the power cord, which is finally connected to the earth via the 3 or 4 prong outlet. What do you mean a 3 or 4 prong outlet? I do not mean a 3 or 4 prong 240 outlet. I'm talking about your 110 outlet. Actually, the third lug in that is the earth ground. If you have a 4-prong outlet, that would be an outlet that actually I'll show it to you right here in 1 second. So here's what it looks like whenever we're talking about the one that driven into the ground. This is actually a power pole that is a much larger that goes to the transformer box. So this one, if you look down right there, it shows I have lighted the earth ground as it goes down into the ground. If you look down at the very bottom, you can actually see the earth ground. Okay, so let's talk about no heat diagnosis. So I come in, the customer calls in and says, I got no heat for my range. So what am I going to check? Whenever I get there, actually before I get there, the first thing I'm going to tell the customer is, did you check the fuse box? And then if the customer says, yeah, I checked the fuse box. And then you get out there and the fuse is blown, you know right there that the customer never checked it. You just flip it back on, see if it sets, and you give them whatever your basic charge is. Tell them thank you and come again. So we're going to check the fuse. If need be, I'm going to reset the breaker. If I don't need to reset the breaker, I can now jump down and test the heating elements. Okay. But all of your heating elements are 240 volts. So to check my bake or broil element, I'm going to set my meter to the lowest ohm scale. Okay. I'm going to use or I could use the resistant sound mode. I prefer to use just the resistant sound mode. Okay, if your bake or broil element reads between 30 and 100 ohms, if not, replacement is required. So if my bake or broil element, if I'm able to do this without having to pull the element out, that's great, because if it's not the element, it will. I don't have to put it back in. Now I will tell you this, that about on elements that have the element exposed, in other words, it's not hidden under a pocket on the bottom. You can use, if I can see that, I can usually look and tell, and I look for a break in that. If I see a break, I know that I have to replace it, and I just go get whichever it is, the bake or the broil. I just go and get that, and now I go and replace it and tell the customer thank you, and I test it. And once I test it, I get all the information and tell the customer thanks, and we move along. Okay, but if something happens and I can't get to the element and I need to check it, you can just go and turn the meter down to the resistance scale like we were talking about. I took my power and my red and my black leads. I'm going to put one on one side, one on the other, and I'm going to measure the resistance. That's where I come through. That slide was a little bit premature. Here it is. It should read somewhere between 30 and 100 ohms. Okay, so I'm looking right here, and if I get between 30 and 100 ohms, my element's okay. If I have it set to the tone scale, all I do is wait for it to get a tone on it. And after I get the tone on it, I'm ready to go. Okay. So if you notice this is a hidden bake and broil element. Okay. So what does that actually mean? Okay. If I open the door to the range, this means I can't look and see the element. It's not exposed. So if I have to replace the bake element, which is the most common one, really, that unless the broil element is the one that is exposed, but I'm going to have the bake is usually that's what everybody uses uses most of the time. So I'm going to replace it a whole lot sooner than I will the broil element. There's a big debate that's out there, and the question is, if I'm going to have to replace the bake element, do I replace the broil element while I'm there, or do I just wait until the broil element goes bad? So I'm going to take a second right here. Somebody tell me how they do it. If I have a bake element that goes out, do I replace the broil element at the same time that I replace the bake element? Yes or no? We got 11 people in the class. I need at least 6 answers with a yes or no. Okay. Well, I'm like, Todd, you're exactly, that's my exact point. The comment that you made. Okay. I don't use my broil element nearly as much as I do my bake element. So no, I do not replace my bake and broil element at the same time. To me, that's totally useless. I'm doing the customer an in service but I have had guys. Yeah, you could do that. You could do that, Johnny. I agree, but the problem is I don't use that broil element nearly as much as I do that bake element. If I go and if I turn the oven on, okay, whenever I first initiate in the bake cycle, it will actually whenever this comes up to temperature, before you get usually there's a tone to let you know that it has reached the temperature that you have set into the unit. You may have alternating bake and broil element cycles. Okay, I would need to know which oven I have. So it's very important that I actually go and look at my manual that I have to see if that's something that I think I may need to discuss with the customer, or is that something that I just Johnny, I agree. Don't replace unless does not what, Johnny? It cut you off, or at least I can't see it. But that's what I do. I don't normally replace the bake and the broil element at the same time. If the bake element is bad, I replace the bake element. The broil element's bad, I replace the broil element. Now, like I was talking about, some of the times you're going to have a hidden bake element, so it doesn't go bad nearly as much as it does with an exposed bake element. One of the things you have to remember, I will tell you right now that let's see, today, this is February. In 3 months, I'll turn 65. And I've been in this business since I was 18 years old. Okay. Whenever I first started, a range came in everything. And most of the time, a lot of the time, the customer will take a sheet of tin foil and place that under the bake element, thinking, hey, I'm going to. Right. I agree with you, Johnny. I'm going to take and put this underneath it, and that'll keep me from having to clean the oven as much. Does that work? What happens if I put a sheet of tinfoil under the element? I will tell you this, that most of the time, what will happen is it will help the element to short out. Okay. It takes a whole lot less time because of all the garbage that gets. Most of the time you have the customer, this kind of customer does not put a pan. I'm going to give you I'm going to say I love to cook. If you look at me, you can tell that I don't miss many meals. But I always put, and I'm going to use an example. If I'm baking ribs, okay, I put them in a tray, or I put them in a thing of tin foil, okay, and I put them on a tray. That helps prevent any spillage that occurs, because that's where your problem usually lies, is in spillage. So I've got a sister that whenever she cooks, she just turns it on clean about 4 times as often as I do, because I put stuff under the whatever I'm cooking, and that allows me to not cause the problems that I'm going to have, that it could lead to. Yes, it overheats and will burn out. You're exactly right, Rupert. And help the element short out. Okay? So, if I have one of these hidden bake elements, I'm going to tell you that most of the time you're going to have to look at the bake element very carefully to see. I mean, the bake in the back to see if I can remove this from the front or if I have to remove it from the back. So, as a technician, how do I know? I look for the 2 screws that are in the back of the unit. Sometimes there are 3. I will say that sometimes, okay? So what am I going to do? If I can remove the element from the front and I don't have to move any of the customer's stuff, I don't have to pull the oven out. That's great. I love that. I don't have to don't have to do it. But if I'm able to remove it from the front, the first thing that I do is I remove the oven door. Okay. You're going to have to know. So that's one of the things that you need to know as a technician. How do I remove the oven door? Okay. If I can remove the bake element from the front, even though it is one of these hidden bake elements, I'm going to have to remove the oven door. It makes it so much faster for me if I just remove the oven door. Okay. After I do that, I remove the racks. Okay. I carry a blanket in my van, and you know what it's for? One of the main things it's for is an oven door and the racks. So I can put the oven door on this blanket. Then I put my racks on top of my oven door, and I'm ready to go. I make sure that I have my racks, my oven door laid face down so that I don't scratch the door. Okay. Once I remove the oven door, then I remove the racks. Then I turn my attention to the 2 screws in the back. Okay. If you look, you're going to be able to see those. If I don't see those 2 screws, I know that I have got to remove this from the back, and I'm going to have to pull the unit out. So what am I going to do then? If I have to remove, if I have to move the oven out, I have my corrugated piece that I put down and slide the oven onto that, and then I'm able to not mess up the customer's floor. Okay, but on this one, I'm able to remove it from the front. So I'm gonna take those 2 screws out. You see one on the right corner. There's one on the left corner over there on the other side. You can see that in the screenshot there. I tried to get two. I should have gone ahead and put the screw on the other side. I should have marked it, but I didn't. So then after I do that, I'm going to lift the back of the unit, back of that little compartment, so that I can slide the back panel up and lift the panel out. So whenever I take my screws out, I have a pick. Okay, it's about this long, and it has a 45-degree angle in it, and it's a dental pick is what it is. But it's sharpened out so that I can stick it under there, lift up the back of this of that part of the oven that's covering the bake element, and then I can lift it up far enough so that I can open it up and then slide that piece out, and I'm ready to go. Okay, and then I can lift that panel out. Then I take that panel, turn it right back around, and lay it on the racks that I have laying out there. Because even if I have to remove the door, I'm going to put the racks out there, and then I'm going to put the rack itself out there. Okay. Once I do that, it gives me this exposure right here. This is the hidden heating element. Okay. If you look in the back on this particular one, there are two screws right there. Okay. On the back corners. Now, if you look on the front, right there on the bottom, you notice there are two other screws. Okay. Most of the time, you're going to find them to be 80 to 90% of the time, they're either going to be a 1/4 inch that or a Phillips head screw. Okay. It's going to be one of those two. Once I take all those out, I'm being very careful. Okay. And I'm gonna ease that out. I can pull it out, and it's going to expose that's going to expose my contacts in the back where my wires are, and I do not have to remove any part of the oven itself. I don't have to remove any part of pull the oven out, so I keep it safe. And I'm good. I'm easy with that. So after I pull this unit out, okay, you can see it right there. Okay, I'm going to lift that element up so that I can get to the wires through the cavity of the oven. Then I'm going to disconnect the wires, ensuring that they don't slip through the back of the cabinet. Be sure that the terminals are safe to reinstall and the new element, and don't show signs of arcing or any thin insulation. So if I pull this out and I pull out a little piece of insulation, I'm going to put that insulation back in. Okay. It's very important. If I don't do that, I cause a heat source, and it will end up arcing and causing problems for me down the road. Okay. So whenever I was doing this, I had a set of pliers that I could lock, and I would lock those in, and I would make it so that I couldn't lose those back into the back side of the oven, because I do not want to have to pull the oven out. It's doing whatever you think is best for you. This is what I found to be best for me. Okay. I had two little sets of those little pliers. They locked in, and I was good to go and get my element, and then bring it back in, and I can just put it right in. Okay. So I'm going to replace in the opposite direction that I removed it, making sure that the terminals fit tightly. After reinstallation, I'm always going to check any of my work. Okay. So whenever I am putting the element back together, okay, I'm going to make sure that those terminals are good and tight. If they're not, I'm going to have to either clamp down and make them good and tight, or I may have to replace that terminal end. Number two, if I have to replace that terminal end, do I use just a regular old wire nut? I'm going to ask you this. You're right, Todd. We never said that everything was always easy, but you're right. Okay. You're exactly right. You never put a regular old wire nut, a red, a orange, or a yellow. Those are not made for an element. Okay, they will melt. You have to. So, what kind of wire nut do I use, Todd? Anybody else? If Todd said that, but if you know the answer, yes, ceramic. Exactly right. You have to use a ceramic nut, wire nut. If you don't use a ceramic wire nut, they will melt and you'll have nothing but problems later on. Thank you, Gino. Right, Johnny. Okay. So once I've done all that, we're ready to go. Okay. So if I have to replace the broil element, I have to remove the broil element. Okay. Most of the time in the broil element, if I have to remove the broil element, I'm going to have to, excuse me. If I have to remove the broil element, I'm going to have to do as I would have done with the bake element. I've got to lower the oven door, take the oven door off, pull off both of the usually there's only two, but sometimes I have seen three of the shelves. I'm going to remove the shelving, put those under on my blanket, and then I can get to my broil element. Okay. To do that, I'm going to make sure that I look, and most of the time with your broil element, there are two in the very front, okay, screws, and then two in the very back screws. So I have got to be sure that I am removing the other one so that I can get this unit out. Okay. Here's the two that are in the back. And then those two that were in the front. Okay. So then pull the element slowly forward. If you do it quickly, you'll have to pull the oven to find the wires. Like, who was that? Todd said. Some of these, I don't know why in the world, Whirlpool, and there's another manufacturer out there that also cuts them off short. And it's like, come on, you could have at least given me an inch or an inch and a half more of it wasn't that expensive, so that I didn't have to go through all this other problems. But as we all know, the engineers have a mind of their own, where they can save a quarter of a cent or a hundredth of a cent. They'll do anything they can. As you notice, most of the time the screws are not magnetized anymore. So I'm going to pull it really slowly forward. We're going to hope that I got enough that I can hold it. Like I said, I always had a little pair of little clamps, hose clamp pliers, that I could snap on and hold that unit, and then remove those two clips off the back. Okay. Here's one of the things you got to remember with a Whirlpool. Some of the Whirlpool broil elements, they do not give you the extra front piece. You have to remove it off of the old one. Okay. So you have to be very careful. And I'm going to make sure that I don't just throw that away and get out because my element will fall, and then I have a whole lot more problems. Okay. So you'll need to remove the oven support bracket from the old element and place it on the new bracket. Now, don't need to do it in all the cases, but you need to be careful whenever you're getting the parts from the parts house. You have to make sure that that's the way that it is. Okay. So we're going to talk about checking igniters on gas ovens. So we're going to move over once whenever we were talking back before, okay, once I remove those, I put my new element in. For me, the easiest thing for me is I check my connections. Once I put the connections and they're good and tight, I push that in first. I'm able to hold that element up and put my screw in from the front bracket of that front part of the bracket. Okay. And I'm left-handed, so I always use the tighten the right screw first, because usually I'm holding the element with my left hand. Okay. And then I'll just swap over and do both in the front. That way I'm sure that I have I have put the element back in that needs to be put it just like it was. And then I can go to the back and replace those two back screws. Okay. I'm going to stop right there. Does anybody have any questions about changing an element? Is everybody good? Okay. Okay, Denise, I'm going to let you be the deciding vote. You said no, so we're going to move on. Okay. Okay. About what is being sold is about I call it the 80-20 rule. Okay. You get about 20% gas and about 80% electric, unless you're in a certain area. But like in Florida, ours was about 80% electric with 20% being gas. It depends on what part of the country you're in. Okay. But this is something you need to know anyway, just so that, because you're going to run up on the untold the gas oven instead of an electric. Okay. I prefer gas. That's me. I think that it's a whole lot more clean, and it is a whole lot more convenient for me to get the pan hot. Okay. Checking on the igniters on a gas oven. How do I check the igniters? Most of the time, if I have an igniter that's bad, I can actually look at the igniter and I will be able to tell if it's bad. Okay, so what happens with the igniter? I get 120 volts coming into the oven control. Then it goes through the oven control into the igniter. From the igniter, it goes into the safety valve. And then that goes to the igniter, goes through the safety valve, and it starts. Okay. So I have to have all of these parts working in sequence, and this is what I need to check if something happens and I do not get a fire whenever I turn the oven on a gas oven. Okay. So one of the things that I'm going to check for is I'm going to check the high limit switch. Okay. So remove the oven from the cavity, place it over place protection on the floor before I pull it out. I'm going to remove all the screws off the back of the oven, check the meter, set it to the ohm scale. I'm going to check for continuity. If I have no continuity, then I'm going to replace that high limit fuse. I will tell you that I have a technician that does on some of these he can fix. if you're looking at the ones on the bottom, excuse me, the one that is on the top left, I'm sorry, the top right, and in the center, in the top, those are not, you can't fix it. But I have a really good technical friend of mine. He takes that. If you look at the one that is right there in the center, that's small, he takes that unit. Will actually take it out to the garage floor, because most of those are concrete, and he'll drop it on the floor. What happens? Whenever it hits the floor, it actually causes the disc that's in the bottom to recompress, and it's good. So some of the times he can do that and not have to replace it right away. I always tell people, if I try this method, I still want to try. This just gets the customer, has the customer a couple of more times that she can use it, maybe until you get back. Okay. So what am I going to do? If the meter is reading 0, what does that tell you? Is the fuse good or bad? Okay. With this set to the ohm scale, my meter is reading 0. What does that tell me? Okay. Where'd it go? Who said that? Gita. Yeah. You're right. It's bad. Okay. If I have nothing going through it, it tells me that it's bad. Where did somebody? Hang on, I'm looking. How are elements high in ohms resistance? Okay, that was the slide that we did. That is between. If I come back and I come back up here, it is between 50 and 130 and 100 ohms. Okay. So if that's my Baker-Broil element, I should get somewhere between 30 and 100 ohms. If not, then I'm going to have to replace it. Okay? Does that answer your question, Gina? Okay. So as we said, if the meter doesn't change or doesn't go to 0, what does that tell you? We just told you right there. It's the same question, just written a different way. Okay. So like we had talked about 3 slides before, right here. Okay. As I go through, I'm getting voltage through to the oven control. Okay. Goes through the oven control. It goes into the igniter. If once this igniter reaches somewhere between 3 to 3.5 amps, that tells the safety valve, hey, it's okay to open. If I get back and I'm not pulling my 3 to 3.5 ohms, I'm going to have to replace that igniter. Like I told you, most of the time, I'm able to look at the igniter and tell if it's bad. Some of the times that doesn't work, though. I have actually, the igniter glowed, but it didn't glow enough, and it didn't. It would never send the safety valve the signal of, hey, we're ready to go. Let the gas flow. So I actually had to replace the igniter, even though it glowed, because it only was pulling 1.2 amps. So it was on its way out. Okay. So once it goes through and it tells the safety valve, I'm ready to open, go ahead and let the gas flow. At that point, My igniter is still lit. The safety valve releases the gas. The gas flows over the igniter. It's at a rate that it now ignites the gas. Once it ignites the gas, okay. Once it ignites the gas, we have a flame, and then it is controlled by the thermostat. Okay. So how am I going to check it out? Like we already said, we're going to go to the ohms or the tone scale. We're going to place one lead on the terminal for the safety valve. Then I'm going to do my red and my black. I'm going to check either of those terminals, and I'm going to see if I get any ohms. If I get 0 to 0.5 ohms, the valve is good. Okay. If my indicator light went out on this diagram, what points would I use to check? Where would I check at it? Okay. For my indicator light. In this diagram, I would go between 3 and N. That would where I would check to see if my indicator light was on. Okay. For my gas oven, if the door switch is a momentary switch. So I've got to know that. Okay. What happened? What pins would I check for the meat probe to know which pins I would go to for the meat probe? It's showing you right there which pins you would go to for the meat probe. If I were doing that, I would go between pin number 1 and pin number 3. That's how I would check my meat probe. This is in a gas oven. Okay. So with a quick look, is that oven gas or electric? Tells you right here it would be a gas oven because I have an igniter. Okay. If my oven light isn't working, what switches need to be closed? My oven light right here. Okay. One thing to remember is this is a door switch, which is right here. So if my oven light wasn't working, what switches, where would I look to check? Okay. That would be, you're going to have to take your wiring schematic and follow it. Okay. So that's where I'm going to, Denise, the indicator light, where do you test 3 and N at? Okay. So if I come right here, okay, that's not it. 3 and N. This is actually on the indicator. It's on the switch itself. Okay. That's where you would check it at. It's on the switch itself. So, well, how did it do that? So on my switch, okay, for the oven, I go between 3 and N, okay, which is those 2 points right there on the switch itself. Yes, Johnny, yes. Well, I'm going to, at this point, I'm going to have to, this one, I'm actually going to have the unit turned on to see if I've got power going to that. I'm sorry, I didn't say that. So I would have to plug this back in to check for power. Wait, okay, that's that. Johnny, yes, an amp meter. I have for a gas oven, I have to have an amp probe. Okay, does that? Yes, neutral. Okay. If you guys have any other questions, let me know. Okay. Our infinite switches. Here's the main reason my infinite switches go out. Okay. Moisture gets up in behind them because somebody's put a pot on the back of the eye, and I've just ruined my infinite switch. A lot of the times I can turn it off, let it sit, and not bother it for a day or so, and then try it afterwards. But I'm going to make sure that it may work or it may not. But this is one of the reasons for failure for an infinite switch. Okay, how do I check my infinite switch? Okay, so what I'm going to do is I'm going to remove the switch from the circuit by unplugging it. Okay, I'm going to make sure that I take a picture of the switch before I unplug it. And this is me. As I have gotten older, this is a tried and true test method. Most of the times these days, they're all in a little plug, and you unplug the whole plug. The old days, whenever I first came, I had to take a picture of this so that I knew exactly which one of those lines went to which plug. Okay. It's easier with this one. It has five wires. Some of the other ones have 8, 9, 10 wires, and you're getting into problems. And I got to know which ones I have hooked up right, because if I don't, I'll blow my infinite switch, and those are not cheap anymore. Okay, so that's the reason I take a picture of it. Okay, I'm going to set my meter to the lowest ohm scale. I'm going to make sure that the switch is turned off. So what I'm going to do is I'm going to take my hand, and you can feel it. What I actually try to do is I turn it to the off position before I remove it. Okay, that's the easiest way for me to do it. But if something happens and it's not, or I don't think it's right, I can actually spin it and feel, and you can tell whenever it pops into the off position. Okay, so once it's in the off position, I'm going to check it. Okay, I'm going to make sure I'm going to use the wiring diagram, and then I'm going to identify the inputs. Okay, so as you can tell on this particular switch, these are the two test points. The blue wire and the blue line and the blue line are one set that I would test. Then I've got the red and the red. That's the second set that I would test. Okay, so terminals directly labeled L1 and L2 on the switch. That is the two at the that is the top two that are at the top. Okay, those will be labeled L1 and L2 on the switch. Okay, then identify the output terminals. Typically, those two are typically labeled H1 and H2. Okay, then I'm go between L1 and H1 to check for continuity. Then I'm going to go between L2 and H2. That'll check for continuity between them. And then as a final check, I'm going to go between L1 and L2 to check for continuity. If I get continuity between L1 and L2, my switch is blown. I should have continuity between L1 and H1 and L2 and H2. I'm sorry, L1 and H1 and L2 and H2. Okay, those are the two. So this is where I'm going to check. And then once I do that and see what I've got, I can check go between the L1 and the L2 and that'll tell me if my switch is good or not. Okay. Here's the fun one that I always have enjoyed since they first came out, a radiant surface element. Okay. These have gotten so much simpler than they used to be. Whenever I was working for who was it? I was working for Viking. I was working for Viking, and they were great. They were great with these radiant surface elements. Of course, this has been probably 12 years ago. So whenever I was working for them, it used to take you about half a day to go and pull the surface elements off of it, these radiant surface elements, because it was such a pain to get to them. Most of the time, you ended up unplugging the whole I used to have to pull it out, unplug the junction box at the very back, take it out to the truck, lay it down so that because it just wasn't easy to get it to work. Okay. So what today's are so much easier than they were back then. Okay. So let's talk about the parts that are on this radiant burner. Okay. So they have the heating coils. They have an inner and an outer coil. They could actually have 3 different coils. They could have a super inner, an inner and an outer coil. Then we have a limiter. What is the limiter? The limiter is what happens whenever I turn this on. It tells the little display, the little red display to light, and that tells me that my element's hot. Okay. From that, I'm gonna use the limiter. That the limiter actually helps cycle it. Also, that's what cycles the burner on and off. Then we've got the plug-in, and we're going to go through and check. Well, I'll show you how to check each one of these out. Okay. One of the things that I'm going to tell you that I really like about the Whirlpool element is that most of the time, if I look on the back of the element, it tells me right there what my part number is. Indicator, you're exactly right. Okay. But one of the things that I love about this Whirlpool Radiant element is that it usually tells me what my part number is. So I can go and I know what my part number is because of this. If you notice, this says W101-69799, and it's a revision B. So I can go to the parts house. I can call my local my local parts guy, which is Encompass, right? And tell him my part number, and I don't have to look it up. One of the other things that I like about the Whirlpool one is that it tells me, okay, how many watts I get. How many watts does this element pull? This one pulls 1,400 watts. Okay. And then it also tells me that this is a 240 volt element. Okay. So there are 3 coils. Okay. You could have a single, you could have one that has a dual coil, and then we could have a triple coil. Okay. Okay. I misspelled that. I apologize. Okay. But I can actually go back and check each one of these to tell if it's any good. So how do I check the burner? Okay. I've got to identify which type it is. Okay. So, and whenever I get done and I order the part, sometimes if the revision is different, I may end up with a different part number than it was whenever I replaced it. And I've got to know, so that I don't blow this burner, I've got to make sure that I look and see how they are. If you notice, some of these are flat, they're just flat straight out. And then I have the other style that is, that has the turn, it's turned up. The tips are turned up. Okay. So if I look at the one that is on the left side, so I'm going to go between 2B, which is the one that's on the top left, to my 1B. Okay. That should give me 240 volts when that's whenever it's done. Okay. That's the hot light circuit. Okay. Whenever it heats up, that is going to, I'm going to have, I will be able to check that to see that I actually have the right, that the light should have come on. Okay. Then I've got the heater coil, which is 2A and 1A. Okay. Then if you look at the next one over, it's totally different. Okay. On the other one, it is a 2B at the very top on the left, and then I have a 1B. Okay. And then I've got a 2A and a 1A, which is the heater circuit on the bottom. What I will tell you is I've got it on the next one. I don't show it on this one. I'll wait and get that on for a minute. Get to that in just a minute. Okay. So one of the other things that I really like about the Whirlpool is it's actually indicated. If you look right at the very, if you look at the one that is on the left, it actually says 2B and 2A right at the very top. Okay, it's imprinted on the coil itself. Okay, so how am I going to check it? I'm going to take 1 meter lead on the common terminal, which is shown right here, and then put the other lead on one of the other ones. So this one only has 2. If I had 3 coils, I would have to go through each one of those. Okay. With the meter set on the lowest ohm scale, look for continuity. If I have it set for sound, if it doesn't make any noise, then that tells me the terminal's bad. That's the way that I check it. Okay, I use the noise feature of my meter. Okay, here it is. When we replace the element, ensure that the terminals are the same by reviewing the terminal on the new bake element. They are engraved on the back of the block. If you look at it right here, it's a little more difficult to see. I wish it was easy as the TC that was labeled right there, but it's not quite as easy. But you can look at it and you can tell, okay, if I'm going to be checking it properly. Okay, so I'm going to stop right here. We're going to go back. And does anybody have any questions so far? Okay, does anybody have any questions? Okay, we're going to go ahead and we're going to move right on along. Okay, so my gas oven, once again, the top 5 reasons that a gas oven will light: the on-off level on the gas valve. Okay, not all gas valves have an on-off lever. Let me tell you that right now. Okay, Could be a bad igniter, could be a bad safety valve, could be a bad infinite switch, could be a bad thermal fuse. There's one more reason out there that I could have an issue. Okay. Can anybody tell me what that other reason would be? And it's not that it won't light, it will light, but you have a whole lot. You're either going to have soot that comes out, or it just won't hardly light at all. And Johnny, we'll get to that in just 1 second. Can anybody tell me what that other one is? And you're only going to find this on a new install. Okay, Todd, you're just about right. Okay. You could be correct. My regulator is what I'm looking for, Denise. If my regulator has actually been turned over wrong, it won't light, or I'll get really bad soot. Okay. All right. So thank you. Thank you there, Denise. If I had a prize, you'd get a prize. Okay. Here's what I was talking about. My on-off lever, if this is turned the incorrect way, it will never get gas. Okay. And this is not on every single gas valve, but about one out of 8 don't have that. Okay. But you need to be careful about that. Okay. Then, like I said, I'm going to look for the obvious. This is what I was telling you. Whenever I'm looking, the first thing I do is I look for the obvious. I look for this if I'm working on a gas dryer, or if I'm working on a gas oven. Okay. I am looking for the obvious. And if I don't get that, then I'm going to have my clamp on amp meter, and I'm going to go between one leg, okay, to check to see if I have my three amps. Okay. So I checked for the amp draw. It should be at least 3.2 ohms for a Whirlpool. Some of the old 1990 and 2000, they were 3 ohms. Okay. To check the continuity through the valve, how am I going to do that? Do you guys know how to check the continuity through the valve? We already touched on it. I'm sorry, I got to have a little salt. My throat is starting to bother me. Okay. How do I check the continuity? Checking the continuity on a gas valve is the easiest thing to do in the world. I'm going to set my meter to the tone scale. Okay. Once I do that, I'm going to place one lead onto one terminal, and then the other lead onto the other terminal. I have to unplug one of the wires. You cannot. It's easier to me to just unplug both of them, but some people like to just unplug one. I like to do both. Okay, so I pull both of those out. I look and see if I have any tone. If I have tone, I'm good. If my meter shows 0 or up to 0.5 ohms of resistance, the value's good. BW, what do you mean, do I? Can you expand on that, BW? What do I what? Okay. I'm going to go ahead and move on. Do we have any questions? This is going to complete our that messed up. It's going to complete our Whirlpool range tips. Does anybody have any questions that we haven't addressed? Guys, I want to thank your time. Thank you for your time. Let me tell you that we wouldn't have these classes if it wasn't for Encompass. They don't charge for any of this. Where are the fuses located at? They're usually attached to the back of the burner, the back of the unit in the. This is the high limit thermostat. Is that what you're talking about, Johnny? Is that what you're talking about? The fuse, the high limit fuse. Hang on just 1 second, guys. I'm trying to get to it. I thought that I actually had it listed, but I do not see where I had it. So let me see if I can come out of here, come into here, and go present, share screen, select tab. Okay, can you see that? That's showing you right there where that high limit is. Okay. If you look at it, you see down there at the very bottom, that's the terminal block. It usually is in between both of the do gas have fuses? Yes. But see, all ovens don't, all ranges don't have these high limit fuses. But yes, they have them also. But this is where you can see it located. So did that, Johnny? Did you get that? Do you see where it should be located? If not, I will try to show you exactly where it is. Okay. All right, guys. Does anybody have any other questions? Thank you guys so much. Renardo, how you been, brother? I'm glad. You'll have to, my number is scrolling across the bottom of the screen. Call me sometime. I wondered what happened with you. So, guys, one thing I'll tell you is you literally will run into each other at training classes, and you'll be trying to figure out, how did I know this guy? Well, and you'll run into them left and right. We're a small community. But guys, let me just state this. It's the obvious. Thank you for your time. Thank you for your attention. I'm going to tell you that this is probably one of the best classes that I've had in probably 7 to 8 months. You guys were very exactly. We got to get out there and start saving appliances. So have a great day. We will see you. I'm here on Tuesdays at 8, 9 o'clock, and on Thursdays at this time. So hopefully I will see you next week. You guys have a great weekend. Talk to you later.